Hi everyone. So for today's video lesson, we will be learning about evaluating functions. So previously we have learned functions and how to determine whether a relation is a function or it's just a mere relation. So let's review that part of our lesson. So here we're going to determine which of the following represents functions. So in number one, we have a set of unordered pairs. And what we're going to do here is we're going to do a diagram or a mapping diagram. So this is to show the correspondence between a domain and the range. So first, we will list down the domain in the first set of ordered pairs. So we have 1, 4, 2, and 7. So these are all the x values of your ordered pairs. And for your range, this is the y values. So we have 3, 1, 0, and 2. So if you can see here that no two ordered pairs have the same first coordinate. So each of the element of the domain corresponds to a unique element of the range. So therefore, this relation is one-to-one, and this set of ordered pairs represents a function. So this is a function. All right, so let's have the second set of ordered pairs. So again, we're going to list down all the domains and the range. So for number two, we have 3, 4. I will not write 3 again because we have 3 here, and 8. And for the range, we have 2, 4, 3, and 9. So we're going to check the correspondence of the elements of the domain to the range. So 3 is paired with 2 and with 3. And our 4 is paired to 4 and our 8 is paired to 9. So observe that our 3 here is paired to 2 and 3. So an element of the domain does not have a unique second element. So therefore, the correspondence is 1 to many. Therefore, the set of ordered pairs does not represent a function. So this is not a function. So for the third example, so we will list down, we will do the mapping diagram again. And we have 1, 2, 3, 4, and 2, 3, 4, and 5. So again here, observe that no two ordered pairs have the same first coordinate. Also, each element of the domain corresponds to a unique element of the range. The relation here is 1-to-1. So the set of ordered pairs represent a function. So this is a function. Now let's move on to the table in number 4. So if you can see from the table here, take note that an input or x value or a domain of -2 and +2 gives an output of 5. And an input of -1 and 1 gives the same output of 2. So the correspondence here is many to 1. So for every value of x, there corresponds a unique value of y or range. Therefore, this table of value or values represents a function. However, in number 5, we can see here, we can observe here that 1, 1, and 1 corresponds to 1, 2, and 3. So this relation again is one to many. So there are three ordered pairs that have the same first coordinate. Therefore, this table of values is not a function. All right, so that is all about function. Now it's time for us to move on to our main lesson. So our main lesson is about evaluating function. And think about this question. How large is the value of the output y in the function y equals to 5x raised to 20 minus 1 if we input x equals to 10? So basically, if we're going to find how large the value is, what we're going to do here is we will just replace our x or the x in the function with a value of 10. So therefore, it would look like this one. 5 times 10 raised to 20 minus 1. So if we're going to evaluate this or simplify this equation, we will get an extremely large number. That would be 5 times 10 raised to 20. So what we just did here is actually a process of evaluating function. So what is evaluating a function? So evaluating a function means replacing the variable in the function. So in the previous example, we replaced the variable x with a value of 10. So in this case, x with a value from the function's domain and computing for the result. Did you know that we are evaluating f at a for some a in the domain of f? We write f of a. So the a here represent any value of your x. So let's have an example. So if f of x equals to 4x squared minus 5x plus 3, evaluate the following. So let's evaluate if the x is equal to 5. So therefore, we have f of 5 is equals to, we will just replace all the x in the equation. So 4 times 5 raised to 2 minus 5 times 5 plus 3. And simplify it. So we get 100 minus 25 plus 3. Therefore, it's equal to 78. Second example, what if our x is equal to 1/4? So we will just replace all the x in the equation, the variable x in the equation with 1/4, and we simplify the equation. So what we have here, so therefore we will have 4 times 1 over 16 minus 5 over 4 plus 3. So therefore, 4 will be canceled out with 16. We will have 1/4 minus 5 over 4 plus 3. So we have negative 4 over 4 plus 3. So the answer here is 2. All right. So let's have the next example. F of 0, replace x with 0. So we will have this equation, and this is equal to 0 minus 0 plus 3. Therefore, the answer is equal to 3. And in this example, our x is equals to square root of 2 over 2. So we will replace all the x, the variable x, with square root of 2 over 2. So therefore, we will have, so this square root here will cancel out with this one, and we will square the denominator. So that means we will have 4 times 2 over 4 minus 5 square root of 2 over 2 plus 3. 4 will be canceled out here. So therefore, we have 2 minus 5 square root of 2 over 2 plus 3. Combine the constant. Therefore, we will have negative 5 square root of 2 over 2 plus 5. So that's the answer. All right, so now let's proceed to the next example. In our previous lesson, we talked about piecewise function, that it is a function defined by two or more formulas on different parts of its domain. So the process of evaluating piecewise function is similar to evaluating the ordinary functions, except for the fact that we need to choose the piece or chunk of functions to be used for a given value of x. We can do this by examining the appropriate interval where the input or the value of x belongs. So we have an example here. Given the piecewise function, h of x equals to x cubed plus 2x, given the conditions that your x should be greater than or equal to 6, and then we have a 3 over 2x with the conditions that your x should be between negative 5 and positive 6, and your x should not be equal to 0. And the third piece of the function is 2 times x plus 4 squared plus 10, given that your x should be less than negative 5. So let's try to find h of negative 10. So first step that we have to do is to determine the piece that should be used in solving this problem. So since negative 10 belongs to the interval of x less than negative 5, therefore we shall use the third piece of the function. And therefore, we have h of negative 10 will be equal to 2 times negative 10 plus 4 squared plus 10. Simplify the equation, we get 2 times 36 plus 10, and that is equal to 82. Second is we're going to find h of 1/2. So again, the first step that we have to do is to determine the piece that should be used. So what do you think? Is it the first piece of the function, the second piece of the function, or the third piece of the function? So in order for you to know which of these three you will use, you have to check where 1/2 belongs in each of the conditions that we have here. So therefore, 1/2 is in the second piece of the function. So 1/2 belongs to the value of x that is between negative 5 and positive 6, except the value of 0. So therefore, we will find h of 1/2 using the second piece of the function, and that would be 3 over 2 times 1/2, and that is equal to 3. For the third part, we will now find out h of 6. So the first piece of the function says that your x here should be greater than or equal to 6. And since our x here is 6, we will use the first piece of the function. So we will just replace the value of x. So we have 6 cubed plus 2 times 6. And that would be equal to 216 plus 12. And our h of 6 would be equal to 228. So that's all for this lesson. If you have any questions,